Hello everyone. Previous lecture we have studied the concept related with the chapter Conics, and in that we define the standard equation of the ellipse, that is standard form of the ellipse. We define equation of ellipse by using here x square upon a square plus y square upon b square is equal to 1. And here we consider only a is greater than b. Okay, this is the one of the standard equation of the ellipse. We show this equation or this figure. This is our figure related with this equation of the ellipse. Here a dash, b and b dash are endpoints or the points on the ellipse. Okay, here we know if the distance sp upon pm is the constant, that is here sp upon pm here is the constant ratio, then this is the eccentricity, and we denote or we define this eccentricity E by using here square root of a square plus b square, a square minus b square upon a. Here L and L dash are the end points of the lattice rectum. Okay, here for the lattice rectum we consider the perpendicular chord, or we consider chord which is perpendicular to the major axis and passing through the focus. Here we have two foci. Here S and S dash are for the foci. Okay, here the length of major axis, that is the length in between A and A dash. Here x-axis is the major axis and length of A and A dash here is twice A. Then here the y-axis is called the minor axis, and here B, length of B and B dash here is 2b. Here note coordinates of A are a0, coordinates of A dash are minus a0, coordinates of B are 0b, and coordinates of B dash are 0 minus b. So here length of major axis is 2a and length of minor axis is 2b. Then here we define the coordinates of foci. Okay, here S is for focus, S dash is also focus, so here we consider two foci. Here coordinates of S are AE0 plus AE0, and for S dash here is a minus AE0. So coordinates of foci are plus minus AE0. Then here we define the distance between the two foci, that is distance in between S and S dash. Here is always twice AE. Remember this, here is twice AE. Then we define equation of directrix. Here D is for directrix, here D dash is for directrix. So since in this figure we have two foci, here we consider two directrix. So distance in between D and D dash, that is distance in between, that is length of Z and Z dash, here is twice AE, sorry 2A upon E. Then here equation of directrix. Here for D we consider x is equal to A upon E plus A upon E, and for this D dash we consider x is equal to minus A by E. So for equation of directrix we consider x is equal to plus minus A by E. Okay, then we define distance between the directrix, these two directrix, that is D and D dash. Here is twice A upon E, and in last your length of lattice rectum, that is the distance in between S and S dash. Okay, here is 2b square upon A. So we define these all formulae in last lecture. Now in today's lecture we go with some important examples related with this table. Okay, so example, here in the first we have to find in first length of principal axis, length of principal axis. Here principal axis means we have to consider major axis and minor axis. That is, we have to find length of major axis and length of minor axis. In second, coordinates of foci. Okay, we know here coordinates of foci are plus minus AE 0. In third, equation of directrix. Next, here length of lattice rectum. In next, distance between foci. And in last, distance between directrix. So we have to find values of these. Here first equation of ellipse is of the ellipse. Here in the first, given x square upon 25 plus y square upon 9 is equal to 1. This is our given equation of the ellipse. Now we know this equation is of the form x square upon a square plus y square upon b square is equal to 1. Here a square is equal to 25 means a is equal to 5. B square is equal to 9 means b is equal to 3. Here a is greater than b. Here we get a is greater than b. Okay. So after comparing this equation with x square upon a square plus y square upon b square is equal to 1. Here we get a square is equal to 25. B square is equal to 9. Therefore, here a is equal to 5 and b is equal to 3. Here we get a is greater than b. Okay, we get a is greater than b. So by using this formulae, we have to find these all points. Okay, let's go with our first point. Here we have to find length of principal axis. Okay, so in point first, we find length of major axis. Here length of major axis is equal to, we know this is 2a, so is equal to 2a is equal to, we know here a is 5, so here we get 2 into 5 and we know 2 into 5 is 10. Here length is 10. Then we find length of minor axis. Here is 2b. Okay, so equal to 2b. This is equal to 2 into b. We know b is 3. So 2 into 3 is, here is 6. So we find the length of principal axis. Now we go with our second point, and in that we have to define coordinates of foci. We know here coordinates of foci are plus minus AE 0. Okay, firstly we have to find this E. We know this E is for eccentricity, and to find the eccentricity, here we use square root of a square minus b square, this divided by a. Okay, now here we know a square, we know a, here a is 5, so a square is 25 minus, we know b is 3, so b square is 9. This divided by, we know a is 5. This is equal to, we know 25 minus 9 is 16 and square root of 16 is 4. So we get 4 by 5. Now we find this AE first, product in between A and E. Therefore here AE is equal to We know AE is a 5. We know AEE is a 4 by 5. Here 5 and 5 are cancelled. Only remains 4. So AE is equal to 4. So we directly define the coordinates of foci. Therefore, coordinates of foci is equivalent to here plus minus AE 0. Okay, this is equivalent to, we know AE is a 4, so here plus minus 4 0. So these are coordinates of foci. Now we go with our next point. Here we have to find equation of directrix. And we know here for equation of directrix, we have x is equal to plus minus a by e. Okay, so in third point, we find equation of directrix. Equation of directrix are here x is equal to plus minus a by e. Therefore, x is equal to, we know A is 5, so plus minus 5 upon E. Here E is 4 by 5, so we replace E by using 4 by 5. And in last, we get X is equal to plus minus 25 by 4. This is the equation of directrix. Now, in next, we have to find the length of lattice rectum. We know length of lattice rectum here is 2b square upon a. So in fourth, length of lattice rectum, this is equivalent to here 2b square upon a. This is equal to here 2 into b square. We know b square is 9. Then this divided by a. Here a is 5. And lastly, we get 18 by 5. So this is length of lattice rectum. Next, here distance between the foci. Here distance between the foci is twice AE. Okay. So using this formula we find distance. Here distance between foci is equivalent to here twice AE is equivalent to 2 into A. Or we know this AE. Here AE is 4 and we know 2 into 4 is 8. Here is 8. Okay, so we find distance between the foci. And in last, here given distance between the directrix. Distance between the directrix. Here distance between the directrix is twice A upon E. Okay, so in last point, point number 6, distance between the directrix here is equal to twice A upon E is equal to here 2 into A is 5. Then this divided by E. We know E is 4 by 5. Here is 4 by 5. And lastly, we get 25 by 2. We get 25 by 2. So for the given equation of the ellipse, here is x square upon 25 plus b square upon 9 equal to 1. We find length of principal axis. Here we find the coordinates of foci. Then equation of directrix. Next, length of lattice rectum. And in last, here distance between the foci, and in last distance between the directrix. So directly by using the this formulae, we find all those points. Okay. Now we go with our next example. Here in next, given, find the equation of ellipse. Find the equation of ellipse in standard form if eccentricity is equal to 3/8 and distance between foci is equal to 6. Now in this example again we have to find equation of the ellipse, and for this here given the eccentricity, also given the distance between the foci, and we know here eccentricity is what and the distance between the foci is what. Okay, so we go with our given things first. Here given, or we consider here equation of ellipse in standard form as x square upon a square plus y square upon b square is equal to 1. Let equation of ellipse is of the form x square upon a square plus y square upon b square is equal to 1. Here also given eccentricity. Here eccentricity is equal to 3/8. We know, or we denote this eccentricity by using small e. Then distance between the foci, here is equal to 6. We know the distance between the foci is here twice AE. We know this is twice AE, so we replace this by using twice AE is equal to 6. Okay, then here we get A, here A as a 6 upon 2E. Therefore, here A is equal to 6 upon 2 into E. We know E is a 3/8, so we replace E by using 3/8. Now, this is equal to, here we get 24 upon 3. Here, 24 upon 3. We know this 24 upon 3 is, here is 8. Here is 8. So, value of A, we get value of A here as 8. Okay, now we get this A here. If A is 8, A square is 64. Now our next one very important step is here, in that we have to find B, and to find B here we know formula of eccentricity or a formula of E. Okay, we know here E is equal to square root of A square minus B square upon A. We have to find this B square. So squaring on both the sides, we get E square is equal to A square minus B square upon A square. Then here we get A square, E square is equal to A square minus B square. We have to find this B square. So I write this as a B square is equal to A square minus A square E square. Now here from these two we keep A square as common, so A square inside the bracket 1 minus E square. We have to find this B square, and we know here A, we know E. So here B square is equal to, we know A is here A is 8, so A square is 64. Here is 64. Then inside the bracket 1 minus E square. E square means, okay, here E is given, E is 3/8, so E square is 9/64. This is equal to 64. Then inside the bracket we know 1 minus 9 by 64. Here is 64 minus 9 means 55 upon 64. Here 64 cancelled and only remains 55. Now we know a square, we know b square. So directly from 1 we get equation of ellipse, and here is x square upon a is 8, so a square is 64 plus y square upon b square. We know b square is 55 and this is equal to 1, and this is the required equation of the ellipse. This is the required equation of the ellipse. So directly by using our formulae, here distance between of foci, and here E, by using E we find the equation of the ellipse. Okay, now we go with our next example. Here in next given, find the equation of ellipse, in standard form, if length of major axis is 10 and distance between foci is 8. Again, we have to find equation of the ellipse. Again, we consider given equation of the ellipse is of the form x square upon a square plus y square upon b square is equal to 1. Let equation of ellipse is of the form x square upon a square plus y square upon b square is equal to 1. Let us consider this as 1. Now we go with given things. Given length of major axis. We know length of major axis is 2a. Okay. Here length of major axis here is equal to 10. We know this length is 2a, so 2a is equal to 10. Therefore here a is equal to 5. We get here a, and here a is 5. Now here also given distance between the foci. Distance between foci here is equal to 8. We know distance between the foci here is twice AE. Therefore, okay, here twice AE is equal to 8. Here this is equal to 8. Therefore, here E is equal to 8 by 2A. Therefore, here E is equal to 8 by 2 into A means 2 into 5. Here is 10 and this is equal to 4 by 5. Here is equal to 4 by 5. Now we get A, we get E. Now we have to find this b square, and to find b square again we use here E is equal to square root of a square minus b square upon a. Then we get E square is equal to a square minus b square upon a square. Next here a square E square is equal to a square minus b square. Okay, then b square is equal to a square minus a square E square. And in last, here b square is equal to a square into 1 minus e square. Now here we know a is 5, we know e, here e is 4 by 5. So we replace This all in this equation. So b square is equal to a square means 25 inside the bracket 1 minus, here e is 4 by 5, so e square is 16 upon 25. In next we get here 25 into bracket 25 minus 16 is 9 and we get 9 by 25. Here 25 and 25 cancelled, only remains 9. So from 1 or using 1 we get equation of the ellipse. Here x square upon a square is, here a square is 25 plus y square upon b square is 9 and is equal to 1. This is the required equation of the ellipse. So a very simple example it is. Directly we use our formula to find the equation of the ellipse. Now we go with our next example. Here in next given, find the equation of the ellipse in standard form if distance between directrix is 18 and eccentricity is 1 upon 3. Again we have to find the equation of the ellipse. Okay, firstly we consider given equation of the ellipse is of the form x square upon a square plus y square upon b square is equal to 1. Let equation of ellipse is of the form, here x square upon a square plus y square upon b square is equal to 1. Let's go with given things. Given distance between the directrix. Distance between directrix here is equal to 18. We know distance between the directrix here is twice a upon e. Here is 2a upon e. Okay, so here I write 2a upon e is equal to 18. This is equal to 18. Okay, here also given eccentricity. Also e is equal to 1 upon 3 is given. Now we replace this e in this second equation, second form. So from 2 we get here twice a is equal to 18 into e. Therefore twice a is equal to 18 into e is 1 upon 3. Then we get here twice a is equal to 6. Twice a is equal to 6. Therefore a is equal to 3. We get value of a and here is 3. Okay, now we have to find b square. We have to find this b square, and to find b square we know here b square is equal to a square into 1 minus e square is equal to, we know a is 3, so a square is 9 into 1 minus e square means 1 upon 3 square. 1 upon 3 square is 1 upon 9. This is equal to 9 into bracket 1 minus 1 by 9 is 8 by 9. Here 9 and 9 cancelled, only remains 8. That is b square is equal to 8. So directly from 1 or using 1 we get we get x square upon a square. Since a is 3, a square is 9 plus y square upon b square. Here b square is 8. This is equal to 1, and this is the required equation of the ellipse. A very simple example it is. Directly we use our formulae to define the equation of the ellipse. Now we go with our next example. Example, find the equation of ellipse. Equation of ellipse in standard form. In standard form, if distance between foci is 6 and distance between directrix is 50 upon 3. Here is 50 upon 3. Okay, so we have to find equation of the ellipse. Let us consider given equation of the ellipse is of the form. Equation of the ellipse is of the form. Here x square upon a square plus y square upon b square is equal to 1. Let us consider this as 1. Now we go with given things. Given here distance between foci. Distance between foci here is equal to 6. We know distance between foci is twice AE. Therefore, here twice AE is equal to 6. This is equal to 6. Then, here also given distance between directrix. Also, distance between directrix here is equal to, here is 50 upon 3. We know here distance between directrix is twice A upon E. Therefore, twice A upon E is equal to 50 upon 3. Is equal to 50 upon 3. Now we know here twice AE is equal to 6. So here E is equal to 6 upon 2A. Okay, and this is equal to, or 6 upon 2A. This E is 6 upon 2A. We replace this E in this expression. So we get twice A upon E is what? 6 upon 2A is equal to 50 upon 3. Then here we get 4A square upon 6 is equal to 50 upon 3. Okay. Then here we get 4A square is equal to 100. 4A square is equal to 100, and lastly here A square is equal to 25. A square is equal to 25 means here A is equal to 5. Here A is 5. Now we replace this A is equal to 5 in second to find the E. So from 2 here we get E. Here E is 6 upon 2 into 5 is equal to here 3 by 5 is our E. Now next step is, here in that we have to find B square, and to find B square we know here B square is equal to A square into bracket 1 minus E square. is equal to, we know a square is 25, inside the bracket 1 minus is what? 3 by 5, and its square is 9 by 25. This is equal to, here 25 into bracket 16 upon 25. Here 25 and 25 cancelled and only remains 16. So directly from 1 we get equation of the ellipse, and is here x square upon a square. A square is 25 plus y square upon b square. B square is 16 and is equal to 1. So this is our required equation of the ellipse. Okay. So in today's lecture we see some important examples related with standard equation of ellipse. Directly by using this table, we solve some examples of ellipse. Thank you.